Hey, it's Plumber-Tom. Don't forget to check in the comments below for a link where you can find additional resources like practice tests and courses that you can take. Your support helps me to be able to create more great content. Thanks for watching. Hello, welcome to this presentation of International Fuel Gas Code, Chapter 5. My name is Thomas, and in this presentation, we are going to look at 503, which is all about the venting of gas appliances. So get out your books, let's have a look. As we start into 503, let me point out this is going to be a lot of information. 503 covers all about vents, and for gas appliances, that's quite a bit. So we'll probably break this up in a couple of presentations, but take note, follow along. And the other thing I'd like to make you aware of is that as I'm going over this, I'm going to take the high altitude view. We're looking down from the airplane. We're seeing all the landscape. I'm going to point to things on the ground. That's my metaphor for how I'm going to go over this book, because there's a lot in this section, and I'm going to try and point out the things that are most relevant to plumbers, maybe the most useful information for installation purposes, but be aware that there's more in here than I'm going to point out, and it's going to be important for you to get in, read that information for yourself, make sure you know what's contained in that chapter, in that section, 503, in case you ever need to look things up later. But let's get into it. First of all, 503.1 says in general, anything that we're going to look at for vent piping is going to be in these sections from 503.2 to 503.16. And may I just clarify, we're not talking about duct venting or other venting. This is specific to gas-fired appliances and the exhaust vents that are run off of that. That's what we're going to look at. How do we run those flue pipes and exhaust pipes, those vents, that convey combustion gases out of the building. 503.2, venting systems required. First of all, big blanket statement here, all appliances shall be connected to venting systems. Now, when we looked at 502, there is a list of some appliances, gas-fired appliances, that don't have to vent out. But overall, it's saying they should be connecting to a vent system. 503.3 says design and construction. These should be designed and constructed so as to convey all flue gases to the outdoors. That's really what we're focusing on in this section. All those appliances that were listed before that don't need to vent out, they don't apply to this. We're looking at running a pipe to get that flue exhaust out. All those gases need to be outside. And these have to be designed and built in a way that that can happen. 503.4 talks about the type of venting system that is to be used. Now, what does that mean? Let's go back to our introduction to this chapter, Chapter 5, where we examined the difference between categories of appliances and the different types of vents that can be applied, be it B vent or C or single wall or whatever. There are different ways, different materials that we can use. And how do you know which one can be used for what appliance or for what category of appliance? That's what 503.4 is all about. And it was referred to back in section 502. It said, we're going to talk about this later in the chapter. So this is really important information as we're installing to know, first of all, what kind of appliance are we dealing with? Be it category 1, category 4, and whichever it is, what kind of materials can we use? Here it is, the table 503.4. You'll want to star this in your book. Make sure you know where this is at, because this gives you, line by line, the different things that can be used. On the left, we have a column of appliances. On the right, a list of types of vents that can be used. So let's look at the most relevant rows here. The top row below appliances, it says listed category 1 appliances. That would be all of your draft vent water heaters and furnaces, but they're about done, right? Most furnaces now are high efficiency and they don't fall into category 1 anymore. But when we're dealing with a tank type water heater with a draft vent, we're a category 1 appliance, what are the types of vents that you can use? Well, there it is listed. Type B gas vent, which is the double wall. You can use that. You can pipe that into a chimney. You can use a single wall metal pipe, and you can also use a listed chimney lining for gas venting, as well as special gas vent listed for these appliances. So any other particulars. Now you see code references next to all of those options, and that's going to tell you more about each of those options. We will be looking at that as we proceed through this section 503. But there you can see, here's your category 1 and the options. Now, what are the most common options that we use? Well, usually it's going to be type B. For most new construction, type B is the double wall. It has a lower clearance from combustibles. It can easily move through. It's more affordable than building a brick chimney. But chimneys have been used for many years. And you also see chimneys with lining, especially for gas venting. There in the mix, as mentioned, was the single wall, but single wall is usually used just for the vent connector. And if you remember from the introduction, the vent connector is what connects the appliance to the vent, the pipe that's running out. The vent itself is the pipe that's going to go all the way through the building. And now that can be a single wall. But again, most of the time we will not use a single wall for the entire vent because it runs at a much higher temperature, and the B vent, the double wall, is a far better option. The next line down here, we got listed vented wall furnaces. They are type BW gas vent, very specific venting for that particular appliance. And then we get into category 2, 3, and 4 appliances. And again, 4 is going to be the high efficiency. Instead of giving us a whole list for each of those, or like we see on the category 1, it just says as specified or furnished by manufacturers of listed appliances. So there are different options, right? Now, if we're installing a tankless water heater, what are we going to do? Well, often we'll run the PVC. And we talked earlier in these presentations about the UL listing, UL 1738, for PVC pipe that's rated for gas venting. But again, that's going to be in the manufacturer's instructions. Like when you're installing that appliance, that's where you need to look for what you can use rather than listed here. Now, see the rest of this, there's a whole bunch of other types of appliances, much less common for plumbers to deal with. They're gas and oil burning appliances, decorative appliances. Many of those can flue or vent into a chimney. I just want to point out, third from the bottom, gas-fired toilets. You can use a single wall metal pipe. I'm sorry. I just think it's a bad idea to burn whatever comes out of a toilet. For the sake of smell, but that may be just me. Whatever, save the world however you want to, but if you're gonna burn your poo, well, use a single wall metal pipe. Moving on. Let's look at a couple of specifics from 503.4. We've got 503.4.1 about plastic piping. It says where plastic piping is used to vent an appliance, the appliance shall be listed for use with such venting materials, and the appliance's manufacturer installation instructions shall identify the specific plastic piping material. Once again, this is in reference to that UL 1738. We looked at this earlier in other presentations, but 503.4, as it talks about plastic piping, lists multiple times. Look in your book. I have it highlighted at least 3 times in those couple of paragraphs below table 503.4, where it specifically states the UL 1738 standard for PVC rated for hot gases. That's what is expected. If we're installing category 4 high efficiency water heaters or furnaces, that's the sort of pipe that should be installed according to code. One other little note when it comes to plastic vent joints. It says that they must be installed in accordance with manufacturer's instructions, the UL 1738, and a primer of contrasting color. Now, does that say purple? No. But what color primer do you know of that's contrasting color? I don't know of any other color primer except purple. There's clear and purple in my world. If you know of another one, awesome. I'd love to know about it. But purple primer. Okay, so I see a lot of HVAC installers who will use only clear glue and possibly primer, but who knows, because if it's clear, you don't know if it's there or not. But I see their pipes. They're nice, they're clean, they don't have runny streaks of purple all over them, but they don't meet code. Maybe they used primer. But the fact is, you should be able to see if you primed that fitting or not. And yeah, I'm sorry if I ran a little bit of purple down the side of the pipe. That's going to be just incidental. It'll happen. But the code says you should be able to tell visually whether you did a good joint or not. And a good joint is going to consist of properly priming the PVC before applying the glue. That's an important part of this chemical process. And if you're doing DWV and you're just installing drains, well, yeah, code has made room for that. Just, yeah, use glue as long as it meets that standard. You don't have to prime up to 4-inch pipe. But that's not what we're talking about here. And we're not talking about just prettying things up in the mechanical room. What we're talking about is making sure it's done right. And according to code, you ought to be putting some color in there. So personally, I'd rather see some streaks. I try to keep it clean, right? Keep that purple primer under control because it's going to run everywhere. But it should be there. It should be a part of the installation. 503.5 gives us information about masonry, metal, and factory-built chimneys. There's a lot of different options for that. And again, for years, the chimney was the go-to. They would build a brick chimney and they would run their vent connectors into that chimney as a vent. So that's still an option. Not something that we install as plumbers very often. So I'm not going to go into the details of what should go into a chimney. But here's a code requirement for those terminations for a chimney. Take a look at 503.5.4. It says, chimney for residential, low heat appliances, shall extend not less than 3 feet above the highest point where they pass through the roof. So at a minimum, a chimney has to go 3 feet above the roof. And not less than 2 feet higher than any portion of the building within a horizontal distance of 10 feet. So if there is a part of the building, either the roof structure or a parapet that's within 10 feet, that vent has to be 2 feet higher than that. What's the purpose for all this? We're trying to get these flue gases up and away into the atmosphere, away from the building, and that's why we got to get these chimney terminals up out of the building. It goes on to say that chimneys for medium heat appliances shall extend not less than 10 feet higher than any portion of the building within 25 feet. So when we're dealing with a higher temperature exhaust, those chimney terminals go up higher. The absolute minimum for a chimney, it says a chimney shall extend not less than 5 feet above the highest connected appliance, draft hood, outlet, or flue collar. So wherever that chimney is connected, and here I have an illustration of a vent pipe or a chimney, 5 feet is the minimum from the appliance to where that terminates. We need enough pipe to get that up and out. Other parts of 503 discuss the inspection of chimneys, chimney service appliances, supporting and cleanouts for chimneys. So there is, again, quite a bit more information that I'm going to dig into when it comes to chimneys. Let's move on to 503.6, and this is where we get into gas vents. As usual, we get a plug for the manufacturer's installation instructions. They say whatever you're hooking up, however you're installing this, make sure you're doing it according to those instructions. There is a very important table with a diagram for us to examine here. It's the gas vent termination for a sloped roof. And this is right in your code book. You've got a nice picture of a roof. Please understand that there are different pitches for a roof. Roof pitch is determined by a ratio of rise over run. It's a triangle, right? The diagonal is the roof, and then we have the distance that it goes up and the distance that it travels horizontal. For a roof slope, we always put horizontal as 12 inches, And then the rise is going to vary depending on the slope, right? So if you have a flat roof, look at the first line here, flat to 612, then the vent has to come up 1 foot over the roof, above the roof. And then on down, we have different ranges of pitch and quite a list of them. And then for those, we see the distance that that vent should come up above the roof depending on the pitch. Now, you'll notice that that increases, right? The distance that the pipe comes up. And the whole point of that is to get the end cap for the vent high enough up away from the roof that the gases from that exhaust won't do any damage to the roof or surrounding structure. So there's that ratio. The more steep the roof, the higher we need to go to make sure those gases are farther away. That's what this table is all about. So, if you're trying to figure out on a question, what is the height above a sloped roof? If you know what the pitch is, you can figure out how high up that needs to go. Have a look with me just above those diagrams of the roof. There is a list of 7 different requirements for gas vent termination. These are some specifics, and depending on different scenarios. The first 2 are in relation to gas vents depending on their size. So it says if it's smaller than 12 inches and is located less than 8 feet from a vertical wall, then we would be sizing it according to the figure that we just looked at with the slope. That's when we'd use that. But what if it's a larger vent pipe that says 12 inches or larger, or if it's less than 8 feet from a sidewall? So now we're getting too close. Then, in those cases, it says that within the 10 feet of any wall, we have to be 2 feet above a vertical structure or the roof. So once again, we see this requirement to get that exhaust up and out. Basically, we need to be 2 feet higher than anything around, including sidewalls, vertical walls, or the roof itself. You can see that in this illustration where the vent's coming out. If it's near enough to the roof, it needs to be 2 feet above that section of the roof. And as we look at 503.6.6, if we're running B vent, which is the double wall off of an appliance, once again, we see the minimum distance at 5 feet. Now, we saw that when we looked at chimneys or chimney type vents. Same thing with the B vent. We can just keep in mind that the shortest that they can go from the appliance to the very top cap, we're talking 5 feet. We see a different requirement in 306.6 specific to a wall furnace, and that would be a minimum of 12 feet. That's going to need a longer flue to get up and out, and that again is dealing with B vent. 503.6.7 talks about the roof termination and basically states that the gas shall extend through the roof flashing, roof jacket, or roof thimble and terminate within a listed cap or a listed roof assembly. So we don't just leave that pipe wide open. It's got to be flashed. It's got to be sealed so that weather can't follow that pipe down and destroy anything down inside the house. Now, when it comes to the removal of exhaust and combustion gases from the building, we're putting those outside, but buildings often have places where they're trying to bring fresh air in for different reasons, maybe for combustion air or forced air inlets. And so we've got to be conscious of the distance between where we're exhausting out and where we're bringing air in. And in 503.6.8, when it comes to forced air inlets, it says that if we're within 10 feet of any location where there's a forced air inlet, we have to be 3 feet above the intake. That's true for any intake that is on a sloped roof, or if we're dealing with a flat roof and there's an air handler or an air unit on the top that's bringing air in. Once again, if we're within 10 feet, we need to have 3 feet above that so that those combustion gases can get up into the atmosphere without being drawn back into the building. Keep in mind that combustion gases, whether they're drafting or they're blown out, are going to be warmer than typical air, and they're going to rise up. And that's what we're trying to help them do, just get up and away from the building. 503.9 talks about exterior wall penetrations.
That should be 503.6.9, sir. Exterior wall penetrations. Thank you.
And it's not uncommon for us to vent out the side wall of a building but there are some places where that would not be allowed. It says a gas vent extending through an exterior wall shall not terminate adjacent to a wall or below eaves or parapets except where provided with section 303.2.3 or 303.3.3. There are some exceptions, but generally you don't want that exhaust pushing out under the eaves. You don't want that exhaust coming out right next to another wall where it could do damage to wall surfaces. So there are certain distances, and we're going to look at exactly where you can and cannot put vents here in just a little bit. 503.6.10 talks about size of gas vents, gives a little bit of information on category of appliances. One of the important things to understand when it comes to the sizing and installation of vents is this principle of vents and vent offsets. So as we size vents, they're going to be sized for a vertical. And a vertical vent is going to allow those gases to escape up and out. Now, what happens if we turn a vent horizontally? Maybe we need to run a horizontal for a little distance to get over to where it can go up and out of the building. That very much affects the movement of gases. It slows them down. It cools them off. And we want them to be going up and out. And because that has an adverse effect on the flow and movement, there are a couple of specific requirements they throw into here. First of all, it's important to understand that a 45-degree offset is still considered a vertical vent, so long as we limit that offset to 2 45s. So if it's coming up into an attic and it just makes sense to move it over here, or I'm trying to get away from something else, keeping distances on the roof, sure, put a couple 45s in, offset that, we're going to still call it a vertical. But if it turns more than a 45, if we're using 60s or 90s, and it's moving laterally, that's going to affect flow. And because of that, we have a limitation on how far it can go horizontally. Now that's total horizontal distance. The connector, which is from the appliance to the vent, and the vent itself, if it moves any distance horizontally. That total horizontal distance from the appliance to where the vent goes out to outdoors is limited by 75% of the height of the vent. So follow me here. If I have a vent that runs 20 feet vertically from the basement out the roof, but I need some horizontal movement to get it to work, I'm limited to 75% of that vertical distance. 0.75 times 20 is 15. I can only move 15 feet horizontally if I'm going up 20 feet vertically. Hopefully that makes sense. But by doing this, we can keep those draft vent gases in motion, which is exactly what we want. 503.6.11 talks about vents serving more than one floor and states that that has to be designed and engineered properly to be able to handle the exhaust from multiple appliances. For purposes of venting, spaces that are below the house, including crawl spaces, are considered another floor. So any of these draft vent appliances that are tied together and running out one exhaust vent have to meet those design requirements. 503.6.12 talks about supporting events, and of course they would need to be supported properly, as we looked at in previous sections. And 503.6.13 says that those vent pipes would have to be marked. 503.6.14 talks about fastener penetrations. We commonly use small screws, fastener screws, to connect our vents and keep them from falling apart. That's great, but when it comes to the use of double wall gas vents, it says that these metal screws should not penetrate the inner wall of that double wall. The point being, the double wall, we're trying to keep those gases on the inside. You might put a screw to fasten those together, but you don't want to drive it through both walls because that compromises the separation. Now, 503.7 gives us a whole section just about single wall vent pipe. And a lot of the requirements are the same as we've already looked at, so I'm just going to point that out. As far as minimum distances from the appliance to the vent terminal, how those vents terminate outside of a roof, a lot of that is the exact same stuff. One thing that's different when it comes to single wall pipe is that it's not rated for cold climates. If you have 99% winter design temperature below 32 degrees Fahrenheit, or in other words, if you have cold winters, lots of ice and snow at times, then running a single wall vent pipe on the outside of the building will not work. Now, why is that? That is because in order for a draft vent to work, there has to be heat. And if that pipe is super freezing cold and you're trying to force hot air into it, it's not going to flow. That exhaust is just going to come right back into the building. And when it's that cold all the time, it's just never going to work. This is where really you don't see this. We run B-vent inside the building for this very reason, to make sure that even during winter, those gases can exhaust right up and out of the building. We're going to pause here in our examination of section 503 from the International Fuel Gas Code. We've gone from 503.1 to 503.7, looking at some of the important things, just getting an overview of what's in there and what's maybe most applicable. Don't forget to look over the whole chapter yourself to make sure you understand what's in there. Next, we're going to go on to 305.8, which is venting system terminal clearances. That'll be in the next presentation. We'll talk all about where you can and cannot bring a vent outside of a building, the distances that are required from openings, all that great stuff. I will see you in the next presentation.